Next we will start isomerism. What is isomerism? Now, isomers are the compounds having the same molecular formula but different structural formula, due to which it has got different physical and in certain compounds also chemical properties differ in certain isomers, due to which it has got different physical properties, and in certain isomers, let me tell you, chemical properties also differs. Alright, so you can say that the two or more compounds having the same molecular formula but different structural formula, due to which it has got different physical and chemical properties, are known as isomers, and the phenomena is known as isomerism. Alright, you can see the definition. In this way, what we find is that isomers, what I said to you, are compounds having the same molecular formula but different structural formula. Alright, and due to the different structural formula, even if the molecular formula is the same, the compounds will be different, and due to difference in compounds, what we find is that the physical properties will differ. As the two compounds are different, let us say one is alcohol, another is ether. Now here not only the physical properties will differ, chemical properties will also differ, because altogether it is a different compounds. Alright, so in certain isomers, for that reason I said the chemical properties as well as physical properties, both it differs. Clear? So hence what we find is that when the molecular formula is the same, listen carefully, when the molecular formula is the same but the compounds are different, two compounds, two or more than two also it is possible, are different, then the compound are known as isomers, and the phenomena is known as isomerism, and hence the physical properties and chemical properties will also differ. Alright, I'll give you examples because it's a chapter, we will see the examples later on. Alright, because when we do the type of isomerism. Now basically isomerism is divided into two types. Isomerism divided into. What is that? The first is your structural isomerism. Structural isomerism, and the second is your stereoisomerism. Stereo. We can see that. Stereoisomerism. Now structural isomerism is divided into, that is chain isomerism, then positional isomerism, then functional isomerism, then metamerism, then ring chain isomerism, then tautomerism. Chain isomerism, positional isomerism, functional isomerism, metamerism, ring chain isomerism, and tautomerism. 1, 2, 3, 4, 5, 6 structural isomerism is divided into. Now stereoisomerism is divided into, that is geometrical isomerism, and the next one is optical isomerism. We can see that in this way. So basically the basic difference between structural and stereo is that, in one word I will say you, this is two-dimensional and this is three-dimensional. This is two-dimensional structural isomerism all, and stereoisomerism basically three-dimensional. Then when I teach you, you will come to know in details about it. But basic difference, if somebody is asking me in one word, you just differentiate it. This is two-dimensional, this is three-dimensional, we can say that. Clear? Now, first we will come to structural isomerism. The first one is your chain isomerism. The first one, chain isomerism. Now, that is in structural isomerism, as I said, the first one is chain isomerism. Now, what is chain isomers? When two or more compounds having the same molecular formula but differs in the arrangement of the primary chain or the main chain are known as chain isomers, and the phenomena is known as chain isomerism. What I said? When two or more compounds having the same molecular formula but differ in the arrangement of the primary chain or the main chain are known as chain isomers, and the phenomena is known as chain isomerism. Alright, like suppose we are having a compound here, like let us say C5H12, let us say pentane C5H12. Alright, now what we find is that C5H12 can be written 1, 2, 3, 4, 5, can be written in this way. Very simple. CH3, CH2, 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 CH3. First one is. Always you write the name so that you will not be confused. So it is N-pentane. N means normal. The first one we got it. Now, what more we can do the arrangement? You think of what more we can do the arrangement. We can make a branch here, isn't it? This is a straight chain, we got it. Normal. Always normal is 1. Straight chain is 1. Alright, then after that the rest are the branches. So this is one branch, we got it in the second position. Fine. Now you put the hydrogen and count it and see whether you are correct or wrong. Because here it is C5H12. Have you counted? 3 to 5 to 7 to 9 3 12. Correct. And 5 carbon. C5H12 correct. Now here you can see. Here that is CH, then CH3, then CH3. Count it and see. 3 to 5, 1 6, 3 9, 3 12. C5H12. Same thing. But what is this name is? It is also called as isopentane. Iso, second carbon atom branching. I told you earlier. When the branching is in second carbon atom, the name starts from the word iso. Or you can say 2-methyl butane. 2-methyl butane. See here, but 4 carbon and second position methyl. 2-methyl butane. Okay. What more you can have it? Any more we can have? Yes, we can have. What more we can have? We can write in this way also. 3 carbon atom in the main chain. See here, CH3, CH3, CH3 and CH3. Count it. 3, 3, 6, 3, 9, 3, 12 and 5 carbon is there. C5H12. 1, 2, 3 or 1, 2, 3 or 1, 2, 3 anyway you do. 3 carbon atom is the main chain. So what it is there? Suppose 1, 2, 3. Then 2, 2 dimethyl 2,2-dimethyl propane. We got it. So we got one straight chain of 5 carbon atom, then a branch chain of 4 carbon atom. Now you will say in the 4 any more we can have it. Yes sir, we can have. We will put the methyl here. Right? Then the counting will be from this side. Same thing, 2-methyl it is. Same thing, it will be 2-methyl. If you count from the, if you put this CH3 here, we will be counting from here rather from here. Same 2-methyl butane. And here 1, 2, 3 you can see. Now 4 carbon atom is over. We can't have any more 4 carbon atoms. Alright, now we'll have 3 carbon atoms in the main chain. So we'll have 2 branches. Can we have any more? No. You see it. For that is the reason I am saying when you are drawing the structure, write the name so that the formula will not be repeated. You might be thinking yes, we will be getting more and more formulas. So hence if you write the name, the formula will not get repeated. The structures will not get repeated. That is what I mean to say. Alright, so hence always it is better to write the name. So how many chain isomers we got it? 3 chain isomers we got it. 3 chain isomers. In this way, we can draw the structures and we can find it. We don't have any shortcut method. Don't ask me, sir, are you having any shortcut method? No, we don't have any shortcut method. And don't think also they will be asking the 40 carbon atoms how much it will be. They will never ask you because it is not possible to draw. Got it? Why I'll say you? Look at here. See, now this one you have understood of the chain isomers. Now, you can remember up to 10. You can remember it, but it's impossible to draw also. See, if one carbon atom 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. One carbon atom means methane. So methane will have how many chain isomers? One only, CH4. Ethane will have how many chain isomers? One only, CH3 single bond CH3. Propane will have how many? One only, CH3 CH2 CH3. Similarly, butane you write it and see you will be having 2 isomers. Butane, see, this is CH3, CH2, CH2, CH3. What is that? It is N-butane. Isn't it? One is N-butane. What more you can have it? 3 carbon atoms. See here. CH3, it is CH, CH3. So what is that we can have? 2-methyl propane. The isobutane we can say that. Isobutane or 2-methyl propane we can see. How many chain isomers we got it? 2 chain isomers. In this way you can draw it immediately, you can find it out. There is no issue. Alright, so for C4, for butane, if it is having 4 carbon atoms, how many chain isomers we can have? That is 2 chain isomers. I am talking about alkanes, understood? Mind with students. Now pentane already we have seen it, that is 3. If you draw it for hexane, it is 5. For heptane, it is nothing but 9. For octane, 18. For it is 35 and this is 75. Okay? Is it possible to draw 35 or 75 isomers? Not possible at all. So don't think beyond that because you cannot draw for C9 and C10. How much you are thinking for 20, 30, 40? It is not possible. Hence it will never come in your exam so much. In your exams maximum it can come up to 7 or 8 carbons. Okay? So you can remember this one. How to remember it? Just like your phone number you are remembering it. 1, 1, 2, 3, 5, 9, 18, 35, 75. From 1 to 10. 1, 1, 2, 3, 5, 9, 18, 35, 75. I remembered in this way. Alright, clear? In this way you can remember it. 1, 1, 1, 1, 1, 2, 3, 5, 9, 18, 35, 75. In this way. These are the number of structure chain isomers in case of alkanes like methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. So this is the number of chain isomers. In this way, in chain isomers, one will be your straight chain and rest will be your branching. We can say that. Clear? Fine. Next, after that, we'll come to that is positional isomers. In the next day, we will see. Thank you.